easier by getting it smaller.
Welcome to Pre-Algebra this Wednesday, October 30th, year of our Lord 2019. Happy birthday, Dad. 80. I know I don't look old enough to have a dad that's 80 years old today. Everyone's like, what? You mean Grandpa? No. Kids call him Grandpa, but Dad turns 80 today. We did on Saturday.
You have a birthday in your family every week.
I hope to see him today. I'm not sure. We had a big party. Big party Saturday here at Carson Party. Okay.
You have like a birthday in your family every week.
And listen, my family from September to October, almost everybody's birthday.
What's your dad's name?
Paul.
They do that on purpose. When's your birthday?
All right, here we go. Yes, sir. The opening question was that Noah was trying to answer. The whole point to doing all this factoring stuff is so that eventually you can find the greatest common factor, which, if you remember from your arithmetic days, helps you reduce fractions. You're going to have fractions that aren't just arithmetic fractions. They're going to have variables in them. So we need to break things down to their smallest parts. And then that's going to help us find the GCF. How? Well, let's get into it. Yesterday, you only had to do 1 through 8 in the middle of page 174. I realized I said you only had to do 1 through 8 because you might not be totally equipped, ready. You might not have been totally equipped and ready to tackle 1 through 8. Let's see how you did. What's the greatest common factor for the two numbers 12 and 18? Some of these you can do in your head, but this is where you need to be headed with this. 12, 18. I'm not saying you had to do this for number, whatever that is, number 1 in the middle of page 174. But you got to get really comfortable with this because you're going to be doing this all the time.
Really?
If I break this down to its prime, I get 2 squared times 3. Amen? Amen. You with me? Amen. Okay. If I to its prime. 2 times 3 squared. Are you with me? Yes. What is arithmetically, in your head, mentally, many of you could figure out the greatest common factor between 12 and 18, and the answer is? 6. Now, how do we arrive at that? By doing prime factorization. If we look at this as 2 times 2 times 3, and this as 2 times 3 times 3, what are our common factors?
2 and 3.
A 2 and a 3. What's 2 times 3?
6.
That's the point, to do all the factoring and getting it down to its prime factors. When you find the prime factors of two numbers, you look at what they have in C, common, and you multiply them together. So you have a 2 and a 3. What's 2 times 3? 6. That's what you thought. That's what you knew the GCF was in your head between 12 and 18. Number 2, what's the GCF between 24 and 60? Again, Brett, knowing his times tables, can figure this out mentally. Hello. Yeah. So what's the prognosis?
Spring.
So here's high, low, lower. Sit down. Right?
Did you just do it?
Last night. So when the guy, went to bed thinking, oh, twisted my ankle at practice, but got up and it wasn't doing better, it was doing worse. So. Okay, number 2, 24 and 60. Again, you know your times tables, so Elise is like, I could figure out the greatest number that goes into both 24 and 60, and she said it was?
I did the wrong page.
No.
So did I.
And Preston said it was 12. Did you do that in your head? Number 3, between 36 and 90, getting a little tougher to do it in your head. What's the greatest common factor between 36 and 90? Zacchaeus in his head can say, oh, I know 9 goes into both because 9 times 4 is 36 and 9 times 10 is 90 from his times tables. But that's not the greatest common factor. That's a common factor. But in order to reduce fractions and save yourself time and only have to do it once, you want to find the greatest common factor. And you found it out to be 18. So if you wrote 9, you found a common factor, but you didn't find the greatest. Now, why didn't you find the greatest? Well, because you were trying to do it arithmetically or in your head. But if you look at number 3 and break it down like this, 36, 90. Give me 2 factors of 36.
6.
Somebody wants to use 6 and 6. Now what?
3, 2.
Done?
Yeah.
What do you want to use?
2.
What am I doing with the 9?
3.
What am I doing with the 10?
5. 3.
Okay, so here I had 1 3 and 2 3s. What was in common? 1 3. Here I had 2 2s and 1 2. What was in common? 1 2. Let me say that again. Let's do that again. When I did this one, and I got 2 times 2 times 3, and 2 times 3 times 3, I looked at the 2s and the 3s were in common, right? How many 2s are in this one?
2.
How many 2s are in this one?
1.
I only use one of them because they each only have 1. They each share 1 2 in common. Come on, engage your mind right now. This is very important. It's going to be going on for the next 2 weeks. How many 2s do they have in common?
1.
How many 3s do they have in common? So I multiplied 2 times 3, and that's how I got 6. Now let's look at this. What's our answer? The answer is 18, not 9. How many 3s do they have in common?
2.
How many 2s do they have in common?
1.
Look, there's a 3 and a 3, a 3 and a 3. They share 2 3s. How many 2s do they share?
1.
There's 2 2s here and only 1 there. So they only share 1 2. How many 5s do they share?
0.
What's 3 times 3 times 2?
18.
That's how you get 18 being the GCF by prime factorization. It's not just that there's 2s and 3s. It's how many 2s and 3s do they share, Sid? Look, because if I was going to use all the 2s and 3s, that wouldn't have made sense. I have 2 2s here and 2 2s there. So I used, 1 2 here and 2 2s there. So I used 1 2. Make sense? Number 4. Your greatest common factor ends up being 24. 12 is a common factor, but it's not the greatest common factor. Number 5. Are those two numbers relatively prime? Remember what that means? Are they prime to each other? Do they share any factors other than 1?
Yes.
They do share factors other than 1, so Zacchaeus. So the answer to the question is no, they're not relatively prime. They're not prime to each other. If that was a fraction, it would have to be reduced. You would have to find a GCF because they're not prime to each other. They do share factors other than 1. How many got 24 as the GCF? Uh-oh. There's only 4 people that got, for number 5, 24 as your GCF? Your first answer was no, they're not relatively prime. Okay, again, you got 12. That's a common factor. It's not the greatest common factor. Can you do that one on the board? 48 and 72?
No, it's 8.
Somebody wants me to. What am I using? Give me something. 6 and 8. Let's break down 6.
3, 2, 3, 4.
Let's break down 8.
4, 2.
Let's break down 4.
2.
Okay, I got 1, 2, 3, 4 2s and 3. Right?
6 and 12. 9. 6 and 12.
Let's break down 9.
3 and 3. 1, 2, 4, 2, 2.
Okay.
3.
How many 2s do they share?
3.
1, 2, 3, 4. 1, 2, 3. How many 2s can I use?
3.
How many 3s do they share?
1.
There's 1 3 there. There's 2 3s here. They only share 1. What's 2 cubed? What's 2 times 2 times 2? 2 times 2 times 2. 8. What's 8 times 3?
24.
What did we say the GCF was?
24.
24. They don't share. This is, no, because 4 is not prime. Everybody get that? They don't share a 4 because it's not at the bottom. It's not prime.
Yeah.
Number 6. Are they to each other? First of all, your first hand is no, they're not prime to each other because they're both even numbers. You know they share at least 2. What's your GCF? Now this might surprise you. Your GCF between 124 and 128, 2 numbers like that, your GCF ends up only being not 2, 4.
Oh, yeah.
Oh, by the way, how could I have done that relying on my divisibility rules I learned back in 5th grade? How do you find out if something's divisible by 4? You look at the last 2 digits. Does 4 go into those digits? Then 4 goes into the whole thing. Does 4 go into 24? Yep. Does 4 go into 28? Yep. Then you would know you'd be able to divide both of those by 4. Number 7. Are they prime to each other? In other words, is there any factor other than 1 that goes into both?
Yes. No.
So they are, the answer is yes. They are prime to each other. So if you had the fraction 39 over 44, could you reduce it? No. There's nothing you can divide both those by. There's no GCF to make it smaller, so that would be already reduced. Amen?
Amen.
And number 8. Are those prime to each other? 263. If you had the fraction 63 over 200, could you reduce it?
Yeah.
Could you divide them both by the same number? What would it be? What do you think? You think you could reduce it?
Yeah.
What would you divide them both by?
3.
200 divided by 3. What's 2 plus 0, 0 plus 0?
2.
Does 3 go into 2?
No.
They are prime to each other, Noah. That would be already reduced. Those look like too big of numbers to not be reduced, but you couldn't reduce it. That's in lowest terms. Got it? Are you ready to, now that you've got milk, are you ready for meat?
Sure.
You understand the analogy there?
I want steak. But
You want steak? Let's go. Let's go then. Let's move to example number 3, bottom of page 174. Now we're not going to work just with numbers. We're working with Elise's favorite, monomials.
Yeah.
First of all, just numbers are monomials because it's just a term, right? Monomial is a fancy word for one term. Well, what makes something one term? For instance, 24 is one term, but so is 6x. Why is 6x one term? Is 6 plus x one term? Nope. 6x is. All written together. They're all multiplied together. Is this making sense? A monomial is where you have written with a coefficient and they're written together. Everything's multiplied together. It makes it 1. 6 plus x, not a monomial. 6x, monomial. Everybody got it?
Yeah.
Okay. Don't get confused by that fancy term monomial. Find the greatest common factor of these monomials. 6x, 18x. Let's work together this. Continue this. Number 9. How are we going to break this down into its smallest parts? Break down 6x. Somebody? What is 6 times x? 6x, if you break it down into prime factors. David? Okay, did everybody follow that? I'm sorry. That was kind of a good message to leave up there. I was kind of working on it. I didn't even realize it was still there. But it's always a good reminder, even in math, to confess your sins, isn't it, there, Mr. Fidel? And why did I write it in red?
Because sin was bad.
What else?
Because Jesus' blood.
Because the power in the...
Red letters.
You know that song? Power in the blood. You guys don't know that song?
There
is power. Wonder working power. Okay. So, confess your sins, you'll be cleansed. All right. 6x, 18x. 6x is 2 times 3 times x. You with me?
Yeah.
What's 8x? I'm sorry.
18.
What's 18x?
2 times 3 times 3 times x. No, it's 6 times 3 times x. No, 3 times 2 times 3
2 times 3 times 3 times x.
I forgot.
What factors do they share? How many 2's?
1.
How many 3's do they share?
1.
How many x's do they share?
1.
What's 2 times 3?
6.
Times x.
X.
What's the greatest common factor? 6x. Now wait. I hope that after I do that and break it down for you and prove to you that it's 6x by prime factorization, I hope you can look at that and see that if this was the fraction, I hope you can see that if you divide them both by 6x, you get 1/3.
Yeah.
Ladies and gentlemen, I hope if your fraction was 6x over 18x, your mind would immediately say 1/3. Because since you found your GCF to be 6x, you would say, okay, divide by x. What's 6x divided by 6x? Anything divided by itself is 1. What's 18x divided by 6x? 3. No, the x's cancel each other out. So why are we doing this? So we can reduce fractions. Number 10. 6xy, 4xy squared. You want me to show you a shortcut?
Yes, please.
If your fraction looked like this, 6xy and 4xy squared. 4xy squared, 6xy. Watch this. What goes into both 4 and 6?
2.
X cancel each other. Y's cancel each other, but I can only cancel one y here. You know what this would be? Just study that for a second while I talk to Spencer. See if you can see what I did there, Preston?
Yeah.
See if you can see what I did there.
Oh.
All right, you were supposed to be studying. You were supposed to be studying this as I was talking to Spencer. Do you get this?
No. I get it. No. Not really. Sort of.
One way to reduce fractions that involve monomials, Zacchaeus, is to recognize that the x's, since there's one of each, they cancel each other out. Because you can think of it like this, Rachel. X divided by x. What's x divided by x?
1.
So you just make those ones. And then I've got two y's up here and one y down here. That cancels this y, and it cancels one of those y's. Make sense?
Yeah.
And the 4 and the 6. What would 4 over 6 reduce to? 2/3. Right? So you would end up with 2, one of these y's got canceled. 2y, 3 times 1 times 1 times 1. I'm sorry, 3 times 1 times 1, 3. 2y over 3 is what you would end up with. Yes?
Don't you, for the two, like, the, no, I don't remember. But wouldn't you do 2 times 4 and 2 times x and, like, not 2 times, but like 4 times 4 x times x?
Would 4 over 6 be 2/3?
Yeah,
Okay. Would x over x be 1?
no.
Anything divided by itself.
Oh, like, never mind. Yeah, I know.
Okay.
I thought you were-
All right? By the way, your greatest common factor here is 2xy. How did we get that, Bella? How did I get 2xy as my greatest common factor for number 10? Does anybody try to do number 10 and factor it out? Hello, could you try to factor out number 10 now? I showed you this shortcut, but now I need you to factor out number 10. You do it and I'll do it. Check your progress with me as I do it on the board. We got 6xy and 4xy squared. If I factor that out, I get 2, 3 times x times y. If I factor this one out, I get 2 times 2 times x times y times y. Right? 2 times 3, prime factors for 6, times x times y. With me?
Yeah.
2 times 2 is the prime factors for 4, 1x times y, because there's 2 y's. What's the process I do now that I got it all down to its basic components, prime factors? I look for common factors. How many 2's over here?
1.
How many 2's over there?
2.
Are they both common?
No.
They're both not common, so I can only use
1.
one of them. How many 3's over here?
0.
I can't use the 3. How many x's over here?
1.
So I can use 1x. How many y's over here?
1.
How many over there?
1.
How many do they share?
1.
1. You can only share one of them. So what's left? 2x, y. That's your GCF.
What does that have to do with the 2 and 3?
Because that's what that, listen, if I divided both of these by 2xy, that's what I would get, 2y and 3. Good? Right there's good. Number 11. Listen, some of you, I'm watching, you're like, this isn't the time to shut down. This isn't the time to tune out when it gets a little challenging. This is the time to really hone in, focus, and tune in. Number 11, 15y, 9x squared, y squared. What's the GCF? Write it. By the way, if you didn't have this written for 10, you should have it written now. So far, Noah and I have figured out that this is 3 times 5 times y. 15 down to its primes is 3 times 5. David says, yep, that's what I got. Zacchaeus is not going to wait until I'm done. He's going to do it while I'm doing it. And Zacchaeus is going to figure out that 9 in its prime factors is 3 times 3. And then he's got times x times y times y. Come on, if you're engaged here, every time we do this, it should be getting a little more clear. It should become a little more clear what we're doing. We're breaking everything down to its smallest parts. And then we go like this. What do they share? How many 3s?
One.
How many 5s? How many x's?
None.
How many y's?
One.
Wait.
Guess what your GCF is?
I see.
3y. You can only use what they share and multiply them together. So if your fraction was 15y over 9x squared y squared, you would divide both top and bottom by 3y. And you would get 5 over 3x squared y. Just in case you want to know that. You don't have to do that yet. That's what you would get. Number 12. 5xy cubed, 10x squared y squared. We should be able to all do this in less than a minute now. 5xy cubed, 10x squared y squared. Is 5 already prime?
No.
Yes.
Who said no?
Oh, well, yeah. I was just.
So this is 5 times x times y times y times y. Who's with me?
Yes.
I was just confused.
Is that getting simple?
Yes.
Mitchell, is 10 prime?
No.
No, but I can easily make that, I can break that into 2 prime numbers. What's 10? 2 times 5. How many x's? Times x times x. How many y's? Times y times y. Come on, this has got to be getting easier now. Now that I have it broken down, I can only use what they share. Is there a 2 in this one?
No.
2, you're out of here. Is there a 5 here?
Yeah.
Is there a 5 there?
Yes.
5 survive. Is there an x here?
Yes.
Is there an x there?
Yes.
Are there 2 x's?
No.
You're out of here.
5.
How many y's?
1.
2.
You're out of here. These 2 y's, I'm sorry. You're out of here. Because they only share 2.
Yes.
So I'm left with a 5, an x.
And 2 y.
Is that a beautiful thing?
Yes.
Just 10 minutes ago, you were like, I have no idea what's going on. Now, you break them down, you put them back together, and here you thought Humpty Dumpty couldn't be put back together. And you did. Humpty Dumpty sat on a wall. Humpty Dumpty had a great fall.
He's an X.
Y'all, kings, horses, and kings, men, you put Humpty back together.
That one they got is so funny. That's a funny. You must have fallen on the sidewalk and it was really hot.
Your homework. Uh-oh, it's Wednesday. What time's this class over?
49.
Oh, you got 6 minutes?
46, we have 3 minutes.
1 through 7. All you gotta do is 175. 1 through 7.
We keep on going.
I already did that. I did it for homework last night. So what do we have to do?
Page 175, 1 through 7.
Yes.
That's it. Page 175, 1 through 7. Hello.
It's gonna be 1 through 0. That's what I have to do.
Like, come look for Ethan. You're collecting his homework.
Oh, this is AB.
Maybe you can do an experiment.
I still have to get caught up on 2.5 hours. I still didn't do